Greetings. Today we are going to talk about the shear force and bending moment. Now, what we need to know so far, we've been dealing with a situation in which we consider that whenever a beam is loaded, that beam will always be in equilibrium because of the fact that the sum of load will always be equal to the sum of reactions. That is the perfect situation, the classic situation. But in reality, we need to be aware of a fact that even though the beam can be in equilibrium, by the fact that the loads are applied on a body, on a rigid body, on a deformable body, which can be a beam, the beam will have a tendency of always be subjected by what we call the twin effect. The twin effect of the loads. Now, the loads that are applied will have a tendency of creating two different effects, which we call the twin effect. The first one is known as the shearing of the beam, or the second one will be what we call the bending of the beam. Now, from what we've learned so far, when we have a beam, we have loads, as I've said before. The sum of load will always be equal to the sum of reactions, and the beam will remain stable. That is on the classic and theoretical aspect. But what takes place is the beam will still gonna be in equilibrium, but it will definitely be taking a certain deflection. Due to what? Due to the effect of the load. And the applied load will subject the beam to two situations. The load will have a tendency of creating what we call a shear effect, and the shear effect takes place on the point load or on the cross section on which the load is acting. And the load is not only a live load, a point load, but it can also be a distributed load. Even distributed load can also cause the same effect. Now, the same effect, either the shearing or the bending, will take place, but if the load are well applied, if they're taking place, they will take place in a safe way. But if they are not well applied, if there is no safety, they will go to the extent of causing a failure. Now, load will always having a tendency of causing a failure on beam, and the failure can happen in two ways. Either by shearing off, which will be, if we take this section, for example, this section C, the load F1 has a tendency of cutting the beam on the section C into two portions in such a way that one portion, one span of the beam, when the load is acting, will have a tendency of sliding on the other one. And whenever the load on the cross section is having a tendency of cutting a beam into two portions at the cross section, with the tendency of sliding one portion or one span of the beam on the other one, this is known as the shearing effect. We call this as a shearing effect. And whenever the load is having a tendency of bending the beam in such a way that the beam is taking a certain deflection to the extent of maybe causing a failure somewhere, this effect is called the bending effect. Now, we need to be aware of this, that whenever load are applied on beams, the load can create two effects. We call them the twin effect. Either it can create a shearing effect by trying to subject the beam to the shear effect, which is the cutting of the beam into two portions and making one sliding over the other one while the beam is acting, or else there could be a bending effect, which is creating a certain bending of the beam or a certain deflection. Now, how do we evaluate the extent of these two effects? The extent of these two effects of bending or shearing effect when a beam is subjected by load, be it live load or distributed load. To define this extent, we need to draw what we call the shear force diagram and the bending moment diagram. These diagrams are the ones that will tell us which section of the beam is likely to be subjected by a bigger shear force, so that whenever there is a failure by shearing effect, that is the section that can be the most suspected. Or whenever there is a bending, that is the point of the beam that could be the most suspected, to the extent of bringing failure by bending or bringing failure by shearing. Now, what is a shear force then? A shear force is the effect of the force trying to shear off the beam, and that is called the shear force. It's that force due to the load that has an impact or an influence of sliding the beam, portion of the beam one over each other while the load is applied, either the distributed load, either the point load. And the shear force will always act at the cross section with the tendency of cutting the beam into two portions to make one portion of the beam to slide over the other one. And how do we find it? We find it on the shear force diagram by doing the algebraic sum of forces that are acting at the left of that cross section or at the right of that cross section. But we need to be aware of the fact that as long as the shear force is acting on a cross section, the impact of the shear force is at the left and at the right of that section. And that's why, to get it, to define the shear force, to determine it, we need to do the sum of the forces that are acting at the left as we're moving along the beam. It is then defined as that force that has a tendency of shearing off, cutting the beam into two portions and making one sliding over the other one. And to determine it, we'll do the sum of algebraic forces at the left or at the right. But its impact is both sides of the beam. Now, when it comes to the bending moment is it's a moment. First of all, as the word says, the bending moment. It's a moment, and we know that any moment is always force times the perpendicular distance to the pivot. But it's the moment that can create a failure by bending excessively a beam. Whenever loads are applied, be it a live load or a distributed load, this load will have a tendency of creating a failure by bending, to the extent, if it's excessive, that failure can cause if the bending is excessive, the failure can take place. If the shearing effect is excessive, the shear effect can take place. And we have a shear force that can be positive or negative, as well as we can have a bending moment that can be positive or negative. We have a positive shear force when there is a shearing effect taking place in such a way that the left part of the beam is going upward. In that case, we're saying that the beam is being subjected by a shear force that is positive. Whenever the left part of the portion of the beam is going up, the shear force is positive. Whenever the left part is going down, the shear force is considered as negative. Now, for the bending moment, we have also positive moment and negative bending moment. Positive moment, which is known as a sagging moment. We call it sagging moment. Sagging moment. It's when the beam is deflected in this configuration. Means we have loads. These are the loads that are applied on the beam, and the beam takes such a bending. This will be called a sagging bending, because the bending is known as, by convention, is known as positive. But if there is this kind of configuration, when the beam is bending, this moment will be a negative. The bending moment coming from this type of bending will be known as a negative moment, called sagging moment. Now, what is important to know is the concept of shear force and the bending moment. How do we define a shear force? How do we define a bending moment? Where is it coming from? Be it shear force or bending moment. You need to remember that whenever a beam is under applied load, be it live load, be it distributed load, the beam will always be subjected by that twin effect of load. And the twin effect will subject a beam either by shearing it, by shearing off, and by bending it. The shearing off takes place at the cross section where the load is applied, or on the area or the length where the distributed load is applied. And the shearing effect will have a tendency of cutting a beam into two portions due to the effect of the load that is acting. And when the beam is being failing by the cutting force, one portion will slide over the other one. And as the portion that is being cut off from the beam is sliding over the other one, we will say there's a punishment or failure of the beam taking place due to shearing off. And the force that is creating the shearing off is known as the shear force. And the shear force is taking place at the cross section, and it's mathematically defined as the sum of algebraic forces acting on the beam at the left of the beam or at the right. But the impact of the shear force is always be both sides, taken both sides of the point load. Now, whenever there's a shear force, we always remember that the load is having a tendency of making a cutoff of the beam on a cross section, making one portion of the beam, one span of the beam sliding over the other one. This is known as a shearing effect, which is one of the mode of failures for beams under applied load. And there's a positive shear force and negative shear force that can be generated when loads are applied on a beam. The shear force is when there's a shearing effect taking place. The left side will be going up. In that case, we're generating a positive shear force. If the left side is going down, we're generating a negative shear force. By the same time, the other effect of the load is trying to bend the beam. And when the beam is taking a bending due to the load applied on that beam, the bending, this effect of bending, or we call it the bending effect. And the bending effect is when the load has a tendency of creating a deflection, an excessive deflection of the beam, and tending to bend the beam to an excessive point. When the beam is taking a deflection is bending due to the force, we're calling that type of failure a bending effect. And to assess the extent of that bending, we'll calculate the bending moment. And the bending moment will be calculated because it's a moment due to, or the moment created by the load. It's a moment due to bending, if we can say so. It means whenever loads are applied, this load will create a bending, and this bending can be excessive to a point of failure. Now, we can have positive bending and we can have negative bending. Now, the very important thing that we need to know is just what is a shear force, what is a bending moment. The bending moment is the moment due to bending, and what creates the bending is the action of the load, be it live load, be it distributed load. And what is a shear force is the effect that the force has a tendency of shearing a beam. It's the failure that can take place during the shearing effect. And the shearing off of the beam is when the force has a tendency of cutting off the spans of the beam, making one sliding over the other. And those are the two aspects of the failure that can take place when beams are loaded. So far, we didn't look at this aspect. So far, we are just looking at the aspect of stability, which is reflected by the equilibrium. And whenever there's stability, there is no deflection. There is no shearing off. That's the classic way of looking at things. But in reality, whenever loads are applied on a beam, there will be a certain deflection that can take place. There could be shearing off of the cross section of the beam. And how do we identify that this point of the beam is likely to be exposed to high failure situation? We identify it by drawing either a shear force or either a bending moment diagram. Shear force and bending moment diagrams are the ones that can tell us exactly which point of the beam is likely to be subjected either to the shear of failure, either to the bending, the excessive bending failure. Now that's what we need to know, that every time there are load applied on a beam, shear force, shear effect can be taking place or bending effect can take place. How do we quantify them? How do we know that this is the point where it could be the more exposed to shear or to bending? It's by presenting, by expressing, or by establishing the diagram of shear force or the diagram of bending moment. Two things to be learned for now is the definition of the shear force and the bending moment. Secondly, why do we learn it? It's because we want to quantify the rate of failure on the beam due to the action of the load. And the failure can take place in two ways: by shearing the beam or by bending the beam. Shearing, a shear force is that force that creates the shearing effect. The bending moment is that moment that creating the deflection or the bending of the beam to the excess. And the shear force or the shear effect takes place when the cutting off has a tendency of breaking the beam, causing a failure in such a way that one portion is sliding over the other one. And the bending effect is when the beam takes a big bending or a big deflection to a point where there could be a failure. How do we determine the shear force? By doing the algebraic sum of the force at the left or at the right. But the impact of the shear force, although the force is acting on a certain point, but the impact is always at the left and also recorded at the right. That's why we need to do the sum of forces either at the left or at the right. But the bending moment, it's just a moment. And a moment is force times a distance to the pivot. Now here we'll apply the sum of moment, algebraic moment on each point that will be considered as a temporary pivot all on the length of the beam. This is what it's all about, the shear force and the bending moment. Then we'll take some examples just in the next session.